Good morning. Welcome to the presentation of our research paper titled Selection of Most Suitable Secondary School Based on Multi-Criteria Fuzzy Analytic Hierarchy Process. We are the authors. I am Muhammad Abdullah Chowdhury. The motivations of our research work is the fact that selecting a school for a child is a very important decision for any parent or guardian, especially in a developing country with limited resources like Bangladesh. Selection of school can shape the future of a young student. It not only affects his or her public exams, but also impact his or her future prospects of a bright career. Now, there are two major problems with school selection process that a guardian might face: the lack of a solid decision-making method and the unavailability of information. A guardian might know which criteria of a school he or she prefers, but he or she does not often know how to use the preference to deduce which school would be good for the student. A guardian also often lacks information about various attributes of the schools, such as teacher-student ratio, distance from home, etc. Our solution to these problems is using Fuzzy Analytic Hierarchy Process, or AHP, for decision making. In our paper, we propose a Fuzzy Analytic Hierarchy process for helping the parents or the guardians to select the most suitable school for his child. Fuzzy AHP was originally introduced by Sati, which combined already known analytic hierarchy process with the usefulness of fuzzy logic for solving multi-criteria decision-making or MCDM problems. We obtained all of our data on schools in Bangladesh Open Data, a government-hosted website aimed at providing datasets on various aspects of Bangladesh, such as agriculture, infrastructure, environment, education, etc., on public domain. We combined multiple datasets collected from this website to form a unified dataset, which contains information like names and addresses of secondary schools, male-female ratio, teacher-student ratio, number of students by age, etc. Using Fuzzy AHP for multi-criteria decision making is quite common. It is very common in solving facility location selection problems. Here you can see some of the examples. We have chosen 6 criteria to determine a school's suitability for a particular user. These criteria are teacher-student ratio, socioeconomic status of the school, male-female ratio, age of school, distance from school to home, and difference of students' age from the average age of the class. We take the guardian's choice of criteria in linguistic terms. The guardian, who is the user of our system, compares each possible pair of criteria and gives inputs in commonly used linguistic values. At first, we take some crisp inputs from the user, such as the student's age, sex, class or grade, and location. We also take comparison inputs in linguistic terms for each pair of criteria. For example, male-female ratio is, quote, absolutely important, end quote, compared to distance from home to school. Another example can be teacher-student ratio is, quote, fairly important, end quote, compared to male-female ratio. We convert these linguistic terms into triangular fuzzy numbers, or TFNs. We express these TFNs in a tuple form. We construct a comparison matrix with these TFNs. For example, if criterion A is, quote, moderately important, end quote, compared to criterion B, then the comparative importance value of criterion A with respect to criterion B in the matrix will be 2, 3, 4, and the value of criterion B against criterion A will be 1 over 4, 1 over 3, 1 over 2 in the matrix. In this matrix, every member Cij is a TFN representing the comparative importance value of ith criterion with respect to the jth criterion. Now, for the defuzzification of our fuzzy inputs, first we take the geometric mean of each row of the TFN values in the matrix. The geometric mean is also a TFN, where the first number is the geometric mean of all the first numbers of TFNs in the row. The second number is the geometric mean of all the second numbers in the row, and so on. From these geometric mean TFNs, we construct a column matrix R, where each row represents the geometric mean of each row of the comparison matrix. Then we calculate a vector V from this column matrix R, We calculate this by getting the arithmetic sum of all the rows of the column matrix R, reversing each sum, and then sorting the reversed values in ascending order. Since for every TFN L, M, U, L is the lowest and U is the highest value, the vector can be obtained in the process shown in the equations. Now we multiply every member of the matrix R individually with V. This gives us the fuzzy weight matrix W as given in the equation. These fuzzy weight values are each criterion is defuzzified using the center of area method. Finally, these crisp values are normalized by their sum as given in the equation. Therefore, by applying this process on matrix C, we get W1, W2, and so on for n criteria. After this, the user selects m alternatives from the list of schools. These schools are compared against each other. We calculate how much the user selected alternatives score in each criterion between 0 and 1 inclusive. Now, for the calculation of some of these criteria scores, we use the cumulative distribution function of standard normal distribution. This method is not applied for all the criteria values, only some of them. The criteria score for male-female ratio is calculated simply by getting the ratio of the number of students with the same sex as the user's inputted sex in the school and total number of the students. For teacher-student ratio and age difference, we use the CDF function since these two numbers are generally not between 0 and 1. The same is done with the age of school attribute, meaning how old the school is. Now, for socioeconomic status, we conducted a survey to assign 15 professions and 7 administrative levels a number between 1 and 10, inclusive, based on their perceptive social status. The data for profession score obtained from the survey is rounded to the nearest multiple of 2.5 to represent 4 distinct social classes. Here, we can see that the professions are categorized into higher, mid-high, mid-low, and lower socioeconomic classes. The administrative levels are also categorized in the same way. In both of these cases, higher number means higher socioeconomic class. Then we calculate a socioeconomic index S for each of these schools by the shown formula. Then these values are normalized, which uses the CDF formula. Finally, for distance, at first we assign a crisp value of D equals 10 for each of the schools. If the school is in the same division as the user's inputted division, we subtract 4 from D. Similarly, if the school is in the same district, Thana, or union or ward, we subtract 3, 2, and 1 respectively. This value of D is used to calculate the score for distance criterion by the shown formula. After gathering all these scores, we construct a comparison matrix for each criterion. At first, for comparing ith alternative to the jth alternative on the nth criterion, we assign an integer CSNij between -10 and 10 inclusive according to the shown equation. These integers are mapped to TFNs according to this table. We take these TFN values and form a comparison matrix. For each criterion, we get a square comparison matrix of dimension equal to the number of schools. In this comparison matrix, a member Aijk represents the comparison TFN of jth school with the kth school based on the ith criterion. Now we apply the same method on these comparison matrices, which give us criteria-wise alternative scores for each of the schools. Finally, we calculate the final score for each school by taking the sum of weighted scores. Now let us go through a demonstration using a real-world problem. Let us assume that a user has given these crisp inputs and these fuzzy inputs. We can notice that the user has chosen distance as the most important criterion, followed closely by socioeconomic status. This would impact the final scores of the alternatives the user chooses. We form a comparison matrix from the fuzzy inputs. Now let us assume that the user has selected 3 schools, A1, A2, and A3. We collect the data on those schools from the dataset and normalize them. For each of the 6 criteria, we construct a 3 by 3 matrix, which yields us criteria scores for each criterion and each alternative. Finally, we take their weighted sum to obtain the final scores. And as you can see, A1 seems to be the best alternative for the user. Now, from the fuzzy inputs, we observed that the user thought distance is one of the two highest priority criteria along with socioeconomic status. For this, the criterion's distance has the highest weight and it actually impacts the result most. The same with socioeconomic status. The user ranks the criteria teacher-student ratio third, but here we see the effect of linguistic terms and corresponding fuzzy numbers. The user has thought teacher-student ratio is important, but only moderately or fairly important, not very or absolutely important. For this reason, this criterion comes in third, but a distant third, and this does not have a lot of effect on the score. The remaining three criteria have very poor relative importance and therefore have less impact on the final score. In a nutshell, this system takes some crisp inputs and a set of fuzzy linguistic values from the user that denote relative importance measures as deemed by the user for every possible pair of these factors. Then it uses Fuzzy AHP to calculate absolute weights for each factor and comparative scores for a few user-selected schools for each criterion. These values are used to assign a final score to each school, which is the measurement of its suitability for the given input. Thank you.